below. In this lecture, we'll find out the length of line segment X using three different methods. In the drawing, we have a right triangle, triangle ABC. Angle ABC equals to 90 degrees. Side AB of the right triangle, triangle ABC equals to 6 units. Side DC equals to 10 units. Angle DAC equals to 45 degrees. And we want to find out the length of line segment AD that is equal to X. So we'll start with the first method, and we will extend line segment AD by a straight line. And then from point C, we will draw perpendicular to the extended AD. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. And we will define the touching point of the perpendicular from point C and the extended AD as point E. And here we have a right triangle. Triangle AEC is a right triangle. And we know that the sum of the angles in the right triangle, triangle AEC, must be equal to 180 degrees. So each angle we have in the right triangle, triangle AEC, we have this angle that is equal to 45 degrees. And we have this angle that is equal to 90 degrees. And we have the missing angle, angle ACE. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we subtract 135 degrees from this equation, and we get that the missing angle, angle ACE, is equal to 180 degrees minus 135 degrees, it is 45 degrees. So we found out that this angle equals to 45 degrees. So actually, in the right triangle AEC, we have two angles that are equal to each other. Both of those two angles are equal to 45 degrees. We'll define line segment DE as Y. Therefore, side AE of triangle AEC will be equal to X plus Y. And we know we have the rule that in front of equal angles in the triangle there are equal sides. So that is to say, in front of those two equal angles there must be equal sides. That is to say, AE must be equal to EC. AE must be equal to EC according to the rule that I mentioned. But AE equals to X plus Y. AE equals to X plus Y. So from this equation, X plus Y equals to AE equals to EC, we will derive that EC is also equals to X plus Y. Okay, EC equals to X plus Y. And we also know that those two angles, they are equal to each other because they are vertex angles. And we have the rule that vertex angles are equal to each other. So I write it down that this angle, angle BDA, angle BDA is equal to this angle, this is actually angle EDC. Angle EDC, according to the rule that vertex angles are equal to each other. So actually we focus on the right triangle, triangle ABD. And on the right triangle, triangle EDC, this right triangle. Okay, we'll focus on those two green right triangles. So if angle ADB is equal to alpha, angle BDA equals to alpha, then from this equation alpha equals to angle BDA equals to angle EDC, we will derive that angle EDC is also equals to alpha. Okay, this angle is also equals to alpha. So in the right triangle, triangle ABD, we know that this angle equals to alpha. So this angle, angle BAD, must be equal to 90 degrees minus alpha in order to complete the sum of the angles in this right hand triangle, triangle ABD to 180 degrees, because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is 180 degrees. That is the reason that this angle must be equal to 90 degrees minus alpha. And for the same reason, angle ECD, this angle must be also equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is 180 degrees. So we actually proved that those two right triangles are similar to each other according to angle similarity rule. And here those two angles, they are equal to each other, they are both equal to 90 degrees minus alpha. So you can write down that angle BAD, this angle, is equal to this angle that is actually angle DCE. And those angles, both those angles are equal to 90 degrees minus alpha. Those two angles are both equal to alpha. And those two angles, they are both equal to 90 degrees. So we can write down that angle ABD, this angle, in the right triangle, triangle ABD is equal to angle DEC, this angle, in the right hand triangle, triangle DEC, and both those two angles, they are equal to 90 degrees. Okay. So we actually proved that all the three angles of the right triangle, triangle BDA, are equal to all three angles of the right triangle, triangle DEC. Those two angles, they are both equal to 90 degrees minus alpha. Both those two angles, they are equal to alpha, and both those two angles, they are equal to 90 degrees. Therefore, we proved that the right triangle, triangle ABD, the right green triangle, triangle ABD, is similar. This is the sign of similar to the right triangle, triangle EDC. The right green triangle, triangle EDC, and they're similar to each other according to angle similarity rule. Okay? And from the fact that the two green right triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that AB over EC, here, we will conclude that AB over EC is equal to BD over DE, and is equal to AD over CD. I'll repeat again. From the fact that the two right green triangles are similar to each other, we will conclude that AB over EC equals to BD over DE equals to AD over CD. Okay, so AB equals to 6 units. It is given us the question, so we will substitute AB by 6. EC equals to x plus y. We will substitute EC by x plus y. And it is equal to BD over DE. DE equals to y, so we substitute DE by y. And it is equal to AD. AD equals to 10 units according to what is given us the question. We substitute AD by 10 over, actually AD here, AD it is here, and it is equal to x. AD equals to x, so we substitute AD by x. And CD equals to 10 units, so according to what is given as the question, so we substitute CD by 10. So in conclusion, we found out that according to equation number 1, 6 over x plus y equals to BD over y equals to x over 10. Here we find out the value of BD, the value of side BD by implementing the Pythagoras theorem on the right green triangle, triangle ABD. So according to the Pythagoras theorem, in the right triangle, triangle ABD, here PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right green triangle, triangle AD, the hypotenuse is AD. So the square of the hypotenuse is AD squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BD squared. plus AB squared. I'll repeat again. According to the Pythagoras theorem, in the right dimensional triangle, triangle ABD, we get that AD squared equals to BD squared plus AB squared. AD equals to X, according to what is given us the question, so AD squared is X squared, and it is equal to BD squared. BD is the missing line segment, so we will leave it as it is. It is BD squared plus AB squared. AB equals to 6 units, according to what is given us the question, so AB squared is 6 squared. 6 squared is 36. So here we will subtract 36 from this equation, and we get that BD squared is equal to X squared minus 36. Here we'll take a root out of this equation, and we get that the size of BD is equal to square root of X squared minus 36. We found out the value of BD. Now we can substitute BD in this equation, equation number 1, by square root of X squared minus 36. We'll do it now, and we'll get that according to equation number 1, (6 over X plus Y) equals to BD, and BD is equal to square root of X squared plus 36 over Y, and it is equal to X over 10. So from this long equation, we will derive the first equation. Those two expressions are equal to each other, so this will be equation number 1. According to equation number 1, we will get that 6 over X plus Y is equal to X over 10. Here we'll cross multiply this equation number 1, and we'll get that according to equation number 1, 6 times 10 is 60, and it is equal to X times X plus Y. Here we will open the brackets on this side of equation number 1, and we'll get that according to equation number 1, 60 equals to X times X is X squared plus XY. Okay, here we'll subtract X squared from this equation number 1, and we'll get that according to equation number 1, XY is equal to 60 minus X squared. We found out the value of XY according to equation number 1. XY equals to 60 minus X squared. In the next step, we create equation number 2 from this long equation. Those two expressions are equal to each other. So I'll write it down. This will be equation number 2, that those two expressions are equal to each other. So according to equation number 2, square root of X squared plus 36 over Y equals to X over 10. Here we'll cross multiply this equation number 2, and we get that according to equation number 2, XY equals to 10 times square root of X squared. So actually X squared minus 26. Here also it is X squared minus 26. So here XY equals to 10 times square root of X squared minus 36. So here we have two different expressions for xy. We have two different expressions for xy. Xy equals to 60 minus x squared according to equation number 1, and xy equals to 10 times square root of x squared minus 36 according to equation number 2. In the next step, we create equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So equation number 3 will be that xy according to equation number 1, that is 60 minus x squared, it must be equal to xy according to equation number 2, that is actually equals to 10 times square root of x squared minus 36. So here we will square both sides of equation number 3, and we will get that according to equation number 3, 60 minus x squared squared is equal to 10 squared is 100, and here the square cancels the root, and we left only with x squared minus 36. Here we will open the brackets on both sides of this equation, equation number 3, and we get that according to equation number 3, 60 minus x squared squared is 60 squared, that is 3600, plus x squared squared, that is x to the power of 4, minus 2 times 60 times x squared, and it is equal to here 100 times x squared, and it is 100x squared, minus 100 times minus 36 is minus 3600. So here we will add 3600 to this equation, equation number 3. And we get that according to equation number 3, 3600 plus 3600 is 7200. And it is equal to 7200 plus x to the power of 4 minus 2 times 60 is minus 120 x squared, and it is equal to minus 100 x squared. Okay, here we'll subtract minus 100 x squared from this equation, equation number 2, and we'll get that according to equation number 3, and we'll get that according to equation number 3, x to the power of 4, and here we have minus 120x squared minus 100x squared is minus 220x squared, plus 7200 equals to 0. Okay? Here we will divide, we will substitute minus 220x squared by minus 180x squared minus 40x squared, and we get that according to equation number 3, x to the power of 4 minus 180x squared minus 40x squared plus 7200 equals to 0. We will divide this expression to two parts, and we will take a common factor from each part. Okay? We will take a common factor from x to the power of 4 minus 180x squared. The common factor will be x squared. So what is left from x to the power of 4 after we took from it x squared is a common factor? What is left, it is actually x squared, and what is left from minus 180x squared after we took from it x squared as a common factor, what is left, it is actually minus 180, and from this expression minus 40x squared plus 7200, we take minus 40 as a common factor. So what is left from minus 40x squared after we took from it minus 40 as a common factor? What is left? It is actually x squared. And what is left from 7200 after we took from it minus 40 as a common factor? What is left? It is actually minus 180. Why? Because minus 180 times minus 40 equals exactly to 7200. So this is equal to 0. And from these two expressions, we take x squared minus 180 as a common factor. Again, x squared minus 180 is taken as a common factor from those two expressions. And what is left from x squared times x squared minus 180 after we took from it x squared minus 180 is a common factor? What is left? It is actually x squared. And here, what is left from minus 40 times x squared minus 180 after we took from it minus 40 as a common factor? After what is left from minus 40 times x squared minus 180 after we took from it x squared minus 180 is a common factor? What is left? It is actually minus 40, and it is equal to 0. So here we have two solutions that are possible for x. The first solution for x will be x squared minus 180 equals to 0. And the second solution for x is that x squared minus 40 equals to 0. So according to the first solution, x squared equals to 180. 180 is 36 times 5. We take a root out of this equation number 1, and we get that according to equation number 1, x is equal to the square root of 36 times square root of 5. Square root of 36 is 6 times square root of 5. So according to equation number 1, x equals to 6 times square root of 5. That is actually 13.41 units. That is greater than 10 units. And according to the second solution, we will get that x squared equals to 40. We take a root out of this equation number 2, and we will get that x equals to the square root of 40. 40 is 4 times 10. So the square root of 4 is 2. So in conclusion, x equals to 2 times square root of 10. That is actually equals to 6.32 units. That is less than 10 units. I repeat again. According to the second solution, we found out that x is equal to 2 times square root of 10 units. That is actually 6.32 units. That is less than 10 units. Okay? So we have two solutions for x. The first solution is x equals to 6 times square root of 5. That is 13.41 that is greater than 10 units, and we have the second solution for x, that x equals to 2 times root of 10, that is 6.32, that is less than 10 units. In the next step, I will copy triangle ABD and triangle ADC in the new page, and we will analyze those two triangles in order to find out which one of the solutions that we found is relevant to our drawing. Okay? So here we have the right triangle, triangle ABD. And we have also triangle ADC. It is given as the question that side DC of triangle ADC equals to 10 units. We know that this angle equals to 45 degrees, angle DAC. We will define angle BAD, this angle is theta. And we know that this angle equals to alpha. Here, inside the right triangle, triangle ABD, we have three interior angles. Angle theta, this angle that is 90 degrees plus, and angle alpha, those three angles, they are defined as the interior angles of the right great triangle, triangle ABD, while this angle, that is actually angle ADC, is defined as an exterior angle of the right great triangle, triangle ADC. So I write it down. Angle ADC is defined as an exterior angle of triangle ADC. Angle ADC, this angle is defined as an exterior angle of this great triangle, triangle ADB. So angle ADC is an exterior angle of the right green triangle, triangle ABD. Okay? So triangle ABD have this exterior angle and three other interior angles. Okay? And we have rule number one that is related to the size of an exterior angle. According to rule number one, the size of an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So I write rule number 1 again. Here, the size. So according to rule number 1, the size of an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So according to rule number 1, the size of this exterior angle, angle ADC, that is an exterior angle of triangle ABD, the size of this exterior angle, angle ADC, is equal to the sum of the two interior angles that are not adjacent to it. If angle alpha is adjacent to this angle, angle ADC, so the other two interior angles that are not adjacent to it, they are theta and this angle that is 90 degrees. And the sum of those two interior angles that are not adjacent to it is 90 degrees plus theta. So we found out that according to rule number 1, angle ADC equals to 90 degrees plus theta. Okay? Because of the fact that the sum of the two interior angles that are not adjacent to it, it is equal to 90 degrees plus theta. Okay, and we know that the sum of the angles in any triangle is equal to 180 degrees, and especially the sum of the angles in triangle ADC must be equal to 180 degrees. So which angles we have in triangle ADC? We have this angle that is equal to 45 degrees. We have also this angle that is equal to 90 degrees plus theta. And we have the missing angle. This angle is equal to angle ACB or ACD. That's angle ACD. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we subtract 135 degrees from this equation. So 135 degrees will get cancelled here, and 100. So what is left here? Theta plus angle ACD is equal to 180 degrees minus 135 degrees. It is 45 degrees. Here we subtract theta from this equation, and we get that the missing angle, angle ACD, is equal to 45 degrees minus theta. So we found out that the missing angle, this angle, angle ACD, equals to 45 degrees minus theta. Okay, and you can see it is very easy to see from the drawing that this angle is the smallest angle in triangle ADC, because it is smaller than 45 degrees, and let alone that it is smaller than 90 degrees plus theta. So we can find out that angle ACD, that is equal to 45 degrees minus theta. This angle is the smallest angle in triangle ADC. In triangle ADC. Okay, I'll repeat again. Angle ADC that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. And we have also rule number 2 that is related to the smallest angle in a triangle. According to rule number 2, the smallest angle in a triangle is always opposite the shortest side. So I'll read rule number 2 again. According to rule number 2, the smallest angle in a triangle is always opposite the shortest side. And we have already found out that this angle ADC, is the shortest angle in triangle ADC. Therefore, according to rule number 2, this angle is opposite the shortest side. Here we know that AD equals to X according to what is given us in the question. So angle ACD is opposite the shortest side. That is to say, AD that is equal to X is the shortest side in triangle ADC. From rule number 2, we will derive that AD that is equal to X is the shortest side in triangle ADC. Okay, because of the fact that the smallest angle is opposite the shortest side, and the smallest angle is angle ACD, it must be that AD that is equal to X must be the shortest side according to rule number 2. Okay, according to rule number 2, AD that is equal to X is the shortest side in triangle ADC. Okay, and because of the fact that AD that is equal to X is the shortest side in triangle ADC, that is to say AD that is equal to X must be less than side DC. Okay, AD that is equal to X must be, it is the shortest side, therefore it must be, it is the shortest side in triangle ADC, therefore it must be less than DC. AD that is equal to X must be less than DC according to rule number 2. But it is given us the question that DC equals to 10. Okay? So from this equation or from this inequality, we will derive that X is less than 10. X is less than 10. So we found out that X is less than 10, and we have two solutions for X. The first solution for X is that X equals to 6 times square root of 5, that is actually 13.41, that is greater than 10. So according to what we have already found out, X must be less than 10 units, and according to this solution, X is greater than 10 units. So this solution is the incorrect solution. We will cancel this solution, and we will left only with the solution, the second solution, that X equals to 2 times square root of 10, that is actually equals to 6.32, that is less than 10 units. So in conclusion, we found out that X it is equal to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units, that is actually, of course, less than 10 units. And that is the answer to the question. In the next step, I will present to you how to find out the value of angle X according to the second method. In the second method, we will do another construction. From point D, we'll draw a straight line on AC in such a way that the angle that will be created will be equal to 45 degrees. Okay? We'll draw a straight line in such a way that the angle that will be created will be equal to 45 degrees. So, here, angle AED equals to 45 degrees according to our construction. Okay? In triangle ADE, we have two equal angles, and we have the rule that if in front of equal angles there are equal sides, that is to say, AD must be equal to DE. AD must be equal to DE, according to the rule that I mentioned, but AD equals to X according to what is given as the question. So from this equation, X equals to AD equals to DE, we will derive that DE is also equals to X. DE is equals to X. We also know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ADE, the sum of the angles must be equal to 180 degrees. So, in triangle ADE, which angles we have in triangle ADE? We have this angle is equal to 45 degrees, and this angle is also equal to 45 degrees, plus the missing angle that is actually angle ADE. In total, the sum of those three angles must be equal to 180 degrees. Okay? Here, 45 degrees plus 45 degrees is 90 degrees. We will subtract 90 degrees from this equation, and we will get that the missing angle ADE equals to 180 degrees minus 90 degrees, it is 90 degrees. So angle ADE is a right angle, therefore triangle ADE is a right triangle. In the next step, we define angle BAD in the right triangle, triangle ABD is theta. So if this angle equals to theta, this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in triangle ABD to 180 degrees. And we actually know that BC is a straight line. Why? Because in triangle ABC, the right triangle ABC, BC is one side of this triangle ABC. So BC is a side of a triangle, must be a straight line. So I'll write it down. Line segment BC is a straight line because it is one side of a triangle. It must be a straight line. A straight line. So we know that BC is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC, at point D, the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So, which angles we have on the upper side of the straight line BC at point D? We have here 90 degrees minus theta, and we have here 90 degrees, and we have the missing angle, that is angle EDC. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of the straight line must be equal to 180 degrees. So here we have 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled, and we left only with minus theta plus angle EDC, that is equal to 0. Here we will add theta to this equation, and we get that the missing angle, angle EDC, is equal to theta. Okay, we found out that the missing angle, angle EDC, equals to theta. In the next step, we will do another construction. From point E, we go perpendicular on BC. So this angle equals to 90 degrees according to our construction, and this angle will be also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point E and BC as F. So in the right triangle, triangle EFD, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. So in the next step, we will prove that those two right triangles can go into each other. So we will actually prove that the right green triangle, triangle EDF, is congruent to the right green triangle, triangle ABD, according to angle side angle rule. Okay, so I write it down. We'll prove that the right triangle, triangle ABD, is congruent to the right triangle, triangle EDF, according to angle side angle rule. So why those two right triangles can go into each other? First of all, those two angles that are equal to each other, they are both equal to theta. So angle BAD in triangle ABD is equal to this angle that is actually angle EDF in triangle EDF, and both angles are equal to theta. I'll repeat again, angle BAD equals to angle EDF, and both angles are equal to theta. Side AD is equal to side DE, and both sides are equal to X. AD equals to DE equals to X. I'll repeat again. Side AD equals to side DE, and both sides are equal to X. And those two sides, they are both equal to 90 degrees minus theta. Therefore, they are equal to each other, of course. So, angle ADB, this angle, is equal to this angle that is actually angle DEF. and both angles are equal to 90 degrees minus theta. I'll repeat again. Angle ADB is equal to angle DEF, and both angles are equal to 90 degrees minus theta. So we actually proved that those two angles at the side that is included between those two angles, that is to say AD, in triangle ABD, can go to those two angles on the side that is included between those two angles, that is side ED, in triangle EDF. Therefore, we proved that those two right angle triangles can go into each other according to angle side angle rule. So I write it down. We actually proved that triangle ABD, again right triangle, is congruent. This is the sign of congruent to triangle EDF according to angle side angle rule. Okay, and from the fact that those two right triangles can go into each other, we conclude that AB is equal to DF. We conclude from it that AB is equal to DF, according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say AB and DF, will be equal to each other. But AB equals to 6 according to what is given us the question. Here AB equals to 6, and from this equation 6 equals to AB equals to DF, we will derive that DF is also equals to 6. Okay, here DF is equal to 6. And what is the value of FC? The value of line segment FC? It is very easy to see from the drawing that FC equals to DC minus DF. Again, DC minus DF equals to FC. So FC equals to DC minus DF. Repeat again, FC equals to DC minus DF. So FC equals to DC. DC, that is 10 units, minus DF, that is 6 units. That is to say, FC equals to 10 minus 6, that is 4. Found out that FC equals to 4 units. And because of the fact that those two right triangles can go into each other, we'll conclude that BD equals to EF. BD equals to EF. Again, BD is equal to EF according to the rule that corresponding sides and congruent triangles are equal to each other. Okay, and if we define side BD as Y, so here BD equals to Y according to our definition. From this equation Y equals to BD equals to EF, we will derive that EF is also equals to Y. EF is also equals to Y. Okay. So we can write here that EF equals to Y. In the next step, we prove that the right triangle ABC is congruent, is similar to the right small triangle EFC. So we will focus on the right triangle ABC, and the right small triangle EFC, and we will prove that those two right triangles are similar to each other according to angle similarity rule. So why the big triangle ABC and the small triangle EFC are similar to each other? First of all, those two angles are equal to each other, they're both right angles. Okay, so angle ABC of triangle ABC is equal to angle EFC of triangle EFC, and both angles are equal to 90 degrees. Okay, angle ABC equals to angle EFC, and both angles are equal to 90 degrees. In addition, this is a common angle. This angle belongs to both triangles. So this angle equals to itself, or we can write down that angle ACB in triangle ABC is equal to angle ECF in triangle EFC. And they are equal to each other because of the fact that this angle is a common angle, it belongs to both triangles. Okay, common angle. I'll repeat again. Angle ACB equals to angle ECF, and both angles, and they are equal to each other because of the fact that this angle is a common angle, it belongs to both triangles. And those two angles, angle BAC and this angle FEC, they are equal to each other according to first angle theorem. So angle BAC, this is the big angle, angle BAC is equal to this angle that is actually angle FEC. I'll repeat again. Angle BAC equals to angle FEC according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. Why? Because they are complementary to 180 degrees. And we proved that those two right angles are equal to each other in the two triangles, and they have also a common angle. Or we can say that those two angles in triangle ABC congruent to those two angles in triangle EFC. Therefore, the third pair of angles, that is to say, those angles must also congruent. Why? Because they are complementary to 180 degrees. Therefore, angle BAC must be equal to angle FEC according to third angle theorem. We actually proved that all the angles of triangle ABC congruent to all the angles of triangle EFC. Therefore, we actually proved that the right big triangle, triangle ABC, is similar to the right triangle, triangle EFC, according to angle similarity rule. Okay? I'll repeat again. We actually proved the triangle ABC is similar to triangle EFC according to angle similarity rule. And from the fact that triangle ABC is similar to triangle EFC, we will derive that AB over BC in triangle ABC is equal to EF over FC in triangle EFC. I repeat again, from the fact that the two right triangles are similar to each other, we will derive that AB over BC equals to EF over FC. Here, AB equals to 6 units, so we substitute AB by 6. BC equals to Y, and BC equals to Y plus 10. Let's see here that BC equals to Y plus 10. So we substitute BC by Y plus 10. And it is equal to EF. EF is Y, and FC is 4. So in conclusion, we found out that according to equation number 1, 6 over Y plus 10 equals to Y over 4. Here we'll cross multiply this equation, equation number 1, and we'll get that according to equation number 1, 6 times 4 is 24, and it is equal to Y times Y plus 10. Here we'll open the brackets on this side of equation number 1, and we'll get that according to equation number 1, 24 equals to Y times Y is Y squared, plus Y times 10 is 10Y. So here we will subtract 24 from this equation, equation number 1, and we get that according to equation number 1, Y squared plus 10Y minus 24 equals to 0. So here we have a quadratic equation. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula. X it is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific quadratic equation, here the coefficient a is equal to 1, the coefficient b equals to 10, and the coefficient c equals to minus 24. And the missing variable that we are looking for is y, so x equals to y. So here we put the data inside the equation for x, and we find out the value of the values of y. And we get that according to this formula, x is equal to y, so y equals to minus b, b is 10, so minus b is minus 10, plus minus square root of b squared, b is 10, so b squared is 10 squared, that is 100, minus 4 times a is 1, times c is minus 24. Over 2a, a is 1, so 2 times 1 is 2. So y equals to minus 10 plus minus 4 times minus 24 is plus 26. 26 plus 100 is 126. So inside the root we have 196 over 2. The square root of 196 is 14. So here we have two solutions that are possible for y. It is minus 10 plus minus 14 over 2. The first solution for y, we define it as y1. y1 equals to minus 10 minus 14 over 2. Minus 10 minus 14 is minus 24. Minus 24 over 2 is minus 12. Okay, the first solution is minus 12. So according to the first solution, y1 equals to minus 12. That is a negative number, but because of the fact, you can see here, y is the length. Y equals to BD, that is one side of a triangle. Y is the length. Y is the length. And as a length, it must be a positive number. Therefore, y1 that is equal to minus 12, that is a negative number, is a correct solution. We cancel this solution, and we're left only with the second solution, y2, that is equal to minus 10 plus 14 over 2. Minus 10 plus 14 is 4, and 4 over 2 is 2. So we found out that y2 equals to 2. Here, y equals to 2, so here I will copy the right triangle ABD in a new page, and we will implement the Pythagoras theorem on the right great triangle ABD. Okay? So in the right triangle ABD, according to the Pythagoras theorem, PT is abbreviation for Pythagoras theorem, we get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AD squared equals to AB squared plus BD squared. AD is x, so AD squared is x squared, and it is equal to AB squared. AB is 6, so AB squared is 6 squared, that is 36, plus BD squared. BD is 2, so BD squared is 2 squared, that is 4. We found out that x squared equals to 36 plus 4, that is 40. We take a root out of this equation, and we get that x equals to the square root of 40. 40 is 4 times 10. So, in conclusion, we found out that x equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. And that is the answer to the question. So in the next step, I will present to you how to find out the value of x according to the third method. In the first method, we define angle BAD as theta, and we define side BD of triangle ABD as y. In the right triangle ABD, you can see that tan as theta is equal to BD over AB. BD is y, and AB is 6, so in conclusion, found out that tan as theta in the right triangle ABD is equal to y over 6. In the next step, we will focus on the right triangle ABC. In the right triangle ABC, you know that tangent theta plus 45 degrees is equal to BC over AB. BC equals to y plus 10 and AB equals to 6. So in conclusion, we found out that in the right triangle ABC, tangent theta plus 45 degrees is equal to y plus 10 over 6. This will be equation number 1. Actually, we have trigonometric identity for tangent theta plus 45 degrees. Tangent theta plus 45 degrees is equal to one plus tangent theta over 1 minus tangent theta. We'll use this trigonometric identity and we will substitute tangent theta plus 45 degrees in equation number 1 by this expression, and we get that according to equation number 1, so tangent theta plus 45 degrees equals to 1 plus tangent theta over 1 minus tangent theta, and according to equation number 1, it is equal to y plus 10 over 6. Okay. Here we will substitute tangent theta by y over 6 because according to what we have already found out, tangent theta equals to y over 6. And we get it according to equation number 1, 1 plus tangent theta, that is y over 6, over 1 minus tangent theta, that is also y over 6, is equal to y plus 10 over 6. Here we will multiply 1 by 6 and then we divide it by 6 in order to have a common factor of y over 6 and minus y over 6, and we get that according to equation number 1, six plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. Okay. So here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled. And we're left only with 6 plus y over 6 minus y equals to y plus 10 over 6. Here we'll cross multiply this equation number 1, and we get that according to equation number 1, 6 times 6 plus y equals to 6 minus y times y plus 10. Here we'll open the brackets on both sides of equation number 1, and we get that according to equation number 1, 6 times 6 is 36, 6 times y is 6y, and it is equal to 6y plus 6 times 10 is 60, minus y times y is minus y squared, minus y times 10 is minus y. So here we have 6y on both sides of the equation, so 6y will get cancelled, and we're left only with 36 is equal to 60 minus y squared minus 10y. Here we will add y squared and also 10y to this equation, equation number 1, and we get that according to equation number 1, y squared plus 10y plus 36 equals to 60. We'll subtract 60 from this equation, equation number 1, and we get that according to equation number 1, y squared plus 10y, 36 minus 60 is minus 24, equals to 0. So we got the same equation the same quadratic equation that we had in the second method. And in order to solve this quadratic equation, we had two solutions to this quadratic equation. This first solution is y1 equals to minus 12, and the second solution is y2 equals to 2. But because of the fact that y1 equals to minus 12 is a negative number and y is a length, it must be a positive number, so we'll cancel this solution. We're left only with the solution that y2 equals to 2. So here we found out that y equals to 2. Now I will copy the right triangle, ABD in a new page, and we will implement the Pythagoras theorem on the right triangle, ABD. According to the Pythagoras theorem and the right triangle, ABD, we will get that according to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. That is to say, AB squared plus BD squared equals to AD squared. AB is 6, so AB squared is 36, plus BD squared. BD is 2, so BD squared is 2 squared, that is 4. And it is equal to AD squared. AD is x, so AD squared is x squared. So we found out that x squared equals to 36 plus 4, that is 40. We take out of this equation and we get that x equals to the square root of 40. That is actually equals to 2 times square root of 10 units. So in terms of numbers, it is equal to 6.32 units. We finished with the first method. In the next step, I will summarize the lecture. Actually, we wanted to find out the length of line segment X, that is actually also equals to AD, the length of this line segment, and in the first method we did the construction. We extended line segment AD by a straight line, and then from point C we drew perpendicular on the extended AD. We defined the touching point between the perpendicular from point C and the extended AD is E. So here we have right triangle, AEC. In this right triangle, AEC, we know that the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle, AEC? We have 45 degrees, we have 90 degrees, and we have the missing angle that is actually angle ACE. In total, the sum of those two angles must be equal to 180 degrees. Okay, 45 degrees plus 90 degrees plus angle ACE must be equal to 180 degrees. We subtracted 145 degrees from this equation and found out that the missing angle, angle ACE, this angle equals to 180 degrees minus 135 degrees, it is 45 degrees. So actually we have here a right triangle that is also an isosceles triangle. Why? Because those two angles are equal to each other, and we know that in front of equal angles in the triangle there are equal sides. That is to say, AE must be equal to EC. We define DE as y, so AE equals to x plus y. So we know that AE must be equal to EC according to the rule that I mentioned, but AE equals to x plus y. So from this equation, x plus y equals to AE equals to EC, we will derive that EC is also equals to x plus y. Okay, then here those two angles are equal to each other according to the rule that the vertex angles are equal to each other. And so if one angle equals to alpha, then the other angle must be also equal to alpha. And in the right triangle, triangle ABD, if this angle equals to alpha, this angle must be equal to 90 degrees minus alpha, because of the fact that together they complete the sum of the angles to 180 degrees. 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is 180 degrees. So this angle must be equal to 90 degrees minus alpha. For the same reason, if this angle equals to alpha, this angle must be equal to 90 degrees minus alpha in the right triangle, triangle EDC. So we actually proved that those two right triangles are similar to each other. Why? Because those two angles are equal to each other, they are both equal to alpha. Those two angles are equal to each other, they are both equal to 90 degrees minus alpha, and those two angles are equal to each other, they are both equal to 90 degrees. Therefore, all the angles of triangle ABD can point to all the angles of triangle EDC. Therefore, those two triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we conclude that AB over EC equals to BD over DE equals to AD over CD. Okay? AB over EC equals to BD over DE equals to AD over CD. AB equals to 6 units, EC equals to x plus y, BD is BD, and D equals to y, AD equals to x, and CD equals to 10. Then we found out the value of BD by implementing the Pythagoras theorem on the right triangle, triangle ABD. When we do the Pythagoras theorem, we get that the square of the hypotenuse equals to the sum of the sides of the perpendiculars, that is to say, AD squared equals to BD squared plus AB squared. AD is x, so AD squared is x squared, BD is the missing line segment, plus AB is 6, so AB squared is 6 squared, that is 36. In conclusion, we found out that x squared equals to BD squared plus 36. We subtracted 36 from this equation, and we found out that BD equals to BD squared equals to x squared minus 36. Then we took out of this equation and found out that BD equals to the square root of x squared minus 36. Now we can substitute BD in this equation, equation number 1, by square root of x squared minus 36. We did it, and we got that according to equation number 1, (6 over x plus y) equals to BD, that is actually square root of x squared minus 36 over y, that is equal to x plus x over 10. From this equation, we created two different equations. The first equation states that those two expressions are equal to each other, that is to say 6 over x plus y equals to x over 10. We cross multiply this equation, equation number 1, and found out that 6 times 10, that is 60, it is equal to x times x plus y. We open the brackets on this side of the equation number 1, and we got that 60 equals to x squared plus xy. We subtracted x squared from this equation and found out that according to equation number 1, xy equals to 60 minus x squared. Then We created equation number 2. According to equation number 2, those two expressions, they are equal to each other. That is to say, square root of x squared minus 36 over y equals to x over 10. Because we multiplied this equation number 2, and we got that xy equals to 10 times square root of x squared minus 36. So we have two different expressions for xy. Then we created equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. Xy according to equation number 1 is 60 minus x squared, and it must be equal to xy to according to equation number 2, that is 10 times square 10 times square root of x squared minus 36. Okay, xy according to equation number 1 must be equal to xy according to equation number 2. Here we squared both sides of equation number 3, and we got that 60 minus x squared equals to 10 squared is 100, and here the square cancels the root, and we left only with x squared minus 36. Then we open the brackets on both sides of this equation number 3, and we got that here 60 minus x squared is 60 squared, that is 3600, plus x squared is x to the power of 4 minus 2 times 60 times x squared. And here it is equal to 100 times x squared, and 100 times minus 36 is 3600. So it is minus 3600. Here we added 3600 to this equation number 3, and we got that 3600 plus 3600 is 7200, plus x to the power of 4, minus here, minus 2 times 60 is minus 180, so this expression equals to minus 180 x squared, and it is equal to 100 x squared. Okay, then we subtracted 100 x squared from this equation number 3, and we got that x to the power of 4, and here we have minus 120 x squared minus 100 x squared is minus 220 x squared, plus 7200 equals to 0. Okay, then we substituted minus 220 x squared by minus 180 x squared minus 40 x squared, and we got that x to the power of 4 minus 180 x squared minus 40 x squared plus 7200 equals to 0. So we divided this expression to two parts. This is the first part, this is the second part, and we took a common factor from each part. From this part, we took x squared as a common factor, and inside the brackets, what is left is x squared minus 180, and from this expression we took minus 40 as a common factor, and inside the brackets what is left is x squared minus 180. Then from those two expressions we took x squared minus 180 as a common factor, and inside the brackets what is left, it is actually x squared minus 40, that is equal to 0. So here we have two solutions that are possible for x. The first solution is x squared minus 180 equals to 0, and the second solution is x squared minus 40 equals to 0. According to the first solution, x squared equals to 180. 180 is 36 times 5. We took the root of this equation number 1, and we got that x equals to 6 times square root of 5, that is 13.41, that is greater than 10 units. And according to the second solution, x squared minus 40 equals to 0, that is to say x squared equals to 40. We took out of this equation, and we found out equation number 2, and we found out that x equals to the square root of 40. The square root of 40 is 2 times square root of 10 units, so in terms of numbers it is 6.32 units, that is less than 10 units. Okay, we have two solutions here. One is greater than 10 units, and the other one is less than 10 units. Okay, then I copied the right triangle ABD, the right green triangle, and the right triangle ADC in this new page, and we analyzed those two triangles in order to find out which one out of the two solutions is relevant, is true in our drawing. In the right green triangle ABD, we have three interior angles that are theta, 90 degrees, and alpha, and angle ADC is defined as an exterior angle of the right triangle ABD. So here, angle ADC is the exterior angle of the right triangle ABD. And according to rule number 1, the size of an exterior angle, of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So according to rule number 1, the size of the exterior angle ADC will be equal to the sum of the two interior angles that are not adjacent to it. The only two interior angles that are not adjacent to it are theta and 90 degrees because of the fact that this angle alpha, is adjacent to it. Angle alpha is adjacent to angle ADC. Therefore, the two other angles that are not adjacent to it are theta and 90 degrees. And according to rule number 1, it is the sum of the two angles that are not adjacent to it, that is to say, the size of angle ADC will be equal to 90 degrees plus theta according to rule number 1. And we know that the sum of the angles in triangle ADC must be equal to 180 degrees. So which angles we have here? We have this angle that is equal to 45 degrees. And we have this angle that is equal to 90 degrees plus theta. And we have the missing angle ACD. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 135 degrees from this equation and found out that theta plus angle ACD equals to 45 degrees. We subtracted theta from this equation and we found out that the missing angle ACD equals to 45 degrees minus theta. And it is very easy to see from the angle ADC that this angle that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. Okay, angle ACD that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. Okay, and we have also rule number 2 that is related to the smallest angle in a triangle. According to rule number 2, the smallest angle in a triangle is always opposite the shortest side. So here, the smallest angle in a triangle is always opposite the shortest side. So here, this is the smallest angle, and according to rule number 2, it is located opposite the shortest side. That is to say, AD that is equal to x, according to rule number 2, it is the shortest side in triangle ADC. Okay, according to rule number 2, AD that is equal to x is the shortest side in triangle ADC. And because of the fact that AD is the shortest side, it must be less than side DC. Okay, so AD is less than side DC, that is equal to 10 units. So from this equation, or from this inequality, we will derive that that x is less than 10 units. Okay, x is less than 10 units, and if the x is less than 10 units, then the solution that x equals to 6 times square root of 5, that is actually 13.41, that is greater than 10 units, will get cancelled, because x must be less than 10 units. So this solution is a correct solution. We're left only with the solution that x equals to 2 times square root of 10 units, that is 6.32 units, that is less than 10 units. So the answer to the question is that x equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method. In the next step, I presented to you how to find out the size of angle theta according to the second method. In the second method, we did another construction from point D. We drew a straight line on AC in such a way that angle AED will be equal to 45 degrees. So according to our construction, we created angle AED that is equal to 45 degrees by drawing a straight line on AC. So here in triangle ADE we have two equal angles, and we know that in front of equal angles in the triangle there are equal sides. That is to say, here AD must be equal to DE. Okay? AD equals to DE. But AD equals to X according to what is given as the question. So from this equation, X equals to AD equals to DE, we will derive that DE is also equal to X. In the right triangle ADE, we know that the sum of the angles is equal to 180 degrees. So which angles we have in the right triangle ADE? We have 45 degrees plus 45 degrees plus the missing angle, that is angle ADE. In total, the sum of those three angles must be equal to 180 degrees. 45 degrees plus 45 degrees is 90 degrees. We subtracted 90 degrees from this equation and found out that the missing angle here, this angle ADE, the missing angle is equal to 180 degrees minus 90 degrees, it is 90 degrees. Okay? Then we defined this angle as theta, and because of the fact that the green triangle is a right triangle, this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in the right triangle to 180 degrees. We know that in triangle ABC, BC is one side of the triangle, therefore it must be a straight line. So BC is a straight line, and we have the rule that the sum of the angles on the upper side of a straight line, the sum of the angles on one side of a straight line is equal to 180 degrees. Again, the sum of the angles on one side of a straight line is equal to 180 degrees. So according to the rule that I mentioned, if we focus on the upper side of the straight line BC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? We have here 90 degrees minus theta, we have here 90 degrees, and we have the missing angle ADF. In total, the sum of those two angles must be equal to 180 degrees. Okay, here 90 degrees minus theta, the first angle plus the second angle that is 90 degrees plus the third angle that is angle EDC. In total, they must be equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees. We have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. And we left only with minus theta plus angle EDC, that is equal to 0. We added theta to this equation and found out that the missing angle here, angle EDC, this angle, this is the missing angle EDC equals to theta. Then from point E, we draw perpendicular on BC. So this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to our definition, according to our construction. And we defined the touching point of the perpendicular from point E and BC as F. So in this right triangle EFD, this angle equals to theta. So this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. Then we proved that those two right triangles can go into each other according to angle side angle rule. Why those two triangles can go into each other? Those two angles, they are both equal to theta, they are equal to each other. Side AD equals to side DE, they are both equal to X. And those two angles are also equal to each other, they are equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that those two angles and the side that is included between those two angles, that is to say AD, in the right triangle ABD, can point to those two angles, and the side that is included between those two angles, that is actually ED, in the right triangle EDF. Therefore, we proved that those two right triangles can go into each other according to angle side angle rule. Okay? And from the fact that those two triangles can go into each other, we will conclude that AB equals to DF. AB equals to DF according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say AB and DF, will be equal to each other. But AB equals to 6 according to what is given as the equation. So from this equation 6 equals to AB equals to DF, we will derive that DF is also equals to 6. When DF is also equals to 6. And then we have what is the value of line segment FC. It is very easy to see from the drawing that FC equals to DC minus DF. Again, DC minus DF equals to FC. Okay, that is to say FC equals to DC minus DF. So FC equals to DC, that is 10 units, minus FC, that is 6 units. That is to say FC equals to 10 minus 6. 10 minus 6 is 4. So we found out that FC equals to 4 units. And because of the fact that those two right-angled triangles can go into each other, we will derive that BD equals to EF according to the rule that corresponding sides of congruent triangles are equal to each other. Okay, BD equals to EF. And if we define BD as Y, then from this equation Y equals to BD equals to EF, we will derive that EF is also equals to Y. Then we proved that the right triangle ABC is similar to the right small triangle EFC. Why those two right triangles are similar to each other? First of all, both those two right triangles have this angle, it is a right angle, it is equal to 90 degrees, therefore they are also equal to each other. They have the common side, the common angle. This angle is common angle that is belongs to both triangles. And those two angles, they are equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem states that if two angles in one triangle can go into two angles in another triangle, then the first pair of angles must also congruent. Okay, and we proved that those two angles in the right triangle ABC can go into those two angles in the right triangle EFC. Therefore, the third pair of angles, those two angles that define the third pair of angles, must also congruent because they are complementary to 180 degrees. So we proved that all the angles of triangle ABC can go into all the angles of triangle EFC. Therefore, from the fact that we derive from it that those two triangles are similar to each other. According to angle, similarity rule. Triangle ABC is similar to triangle EFC, according to angle, similarity rule. And from the fact that those two triangles are similar to each other, we will derive that AB over BC equals to EF over FC. Again, AB over BC equals to EF over FC. Okay, AB over BC equals to EF over FC. AB is 6, BC is Y plus 10, EF is Y, and FC is 4. Okay, because multiply this equation number 1, and we found out that 6 times 4 is 24, and it is equal to Y times Y plus 10. We open the brackets on this side of equation number 1, and we found out that 24 equals to Y times Y is Y squared, and Y plus 10 is 10Y. We subtracted 24 from this equation, and we got that Y squared plus 10y minus 24 equals to 0. So this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, a equals to 1, b equals to 10, and c equals to minus 24, and the missing variable is y, so x equals to y. So we put the data inside the formula for x, and we find out the value of the values of y, because x equals to y. So here y equals to minus b, b is 10, so minus b is minus 10, plus minus b squared. B is 10, so b squared is 10 squared, that is 100. Minus 4 times a is 1, c is minus 24. So it is minus 4 times minus 24, that is plus 96, and plus 96 plus 100 is 186. So here, and the square root of 196 is 14. So here we have two solutions for y. The first y equals to minus 10 plus minus 14 over 2. So the first solution for y is y equals to minus 10 minus 14 over 2. That is actually minus 12. But because of the fact that y is a length, y is the length of side BD, it must be a positive number, so this solution is a correct solution. We cancel the solution and we left only with the solution that y equals to minus 10 plus 14 over 2. Minus 10 plus 14 is 4, and 4 over 2 is 2. So we found out that y equals to 2, AB is 6, and AD is x. So we implemented the Pythagoras theorem on this right triangle ADB. According to the Pythagoras theorem, the square of the hypotenuse is equals to the sum of the squares of the perpendiculars. That is to say, AX squared equals to AB squared plus BD squared. AD is x, so AD squared is x squared, and it is equal to AB squared. AB is 6, so AB squared is 6 squared, that is 36, plus DB squared. BD squared, BD is 2, so BD squared is 2 squared, that is 4. So we found out that x squared equals to 36 plus 4, that is 40, or x squared equals to 40. We took out of this equation and we found out that x equals to the square root of 40, and the square root of 40 is 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the second method. Then I presented to you how to find out the value of line segment x according to the third method. In the third method, we defined angle BAD as theta and BD as y. In the right triangle ABD, triangle theta equals to BD over AB. BD is y, AB is 6, so in conclusion found out that triangle theta equals to y over 6, and in the right triangle ABC, triangle theta plus 45 degrees equals to BC over AB. Okay, triangle theta plus 45 degrees equals to BC over AB. BC is y plus 10, AB is 6. So triangle theta equals to y plus 10 over 6. According to equation number 1. Then we substituted we have a trigonometric identity. The triangle theta plus 45 degrees equals to 1 plus triangle theta over 1 minus triangle theta. So we substituted triangle theta plus 45 degrees in equation number 1 by this expression, and we got that according to equation number 1, 1 plus triangle theta over 1 minus triangle theta equals to y plus 10 over 6. Then we substituted triangle theta by y over 6 because triangle theta equals to y over 6, and we got that 1 plus y over 6 over 1 minus y over 6 equals to y plus 10 over 6. Then we multiplied 1 by 6 and then we divided by 6 in order to have a common factor with y over 6 and with minus y over 6, and we got that 6 plus y over 6 minus y over 6 equals to y plus 10 over 6. Here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled, and we left only with 6 plus y over 6 minus y equals to y plus 10 over 6. We first multiply this equation number 1, and we got that 6 times 6 plus y equals to 6 minus y times y plus 10. We open the brackets on both sides of the equation, and we got that 6 times 6 is 36, plus 6y, plus 6y, plus 6 times 10 is 60, minus y times y is minus y squared, minus y times 10 is minus 10y. We have 6y on both sides of the equation, so 6y will get cancelled, and we left only with 36, that is equal to 60 minus y squared minus 10y. We added y squared and also 10y to this equation number 1, and we got that y squared plus 10y plus 36 equals to 60. We subtracted 60 from this equation, and we found out that y squared plus 10y minus 24 equals to 0. This quadratic equation is the same quadratic equation that we got in the second method, and the solution to this quadratic equation is, it has two solutions. The first solution is y1 equals to minus 12, and the second solution y2 equals to 2. But because of the fact that y is a length, it cannot be a negative number, so this solution will get cancelled, and we left only with the solution that y2 equals to 2. So here we found out that y equals to 2 units, AB is 6 and AD is x. We implemented the Pythagoras theorem on this right triangle, triangle ABD, and we got that AB squared plus BD squared equals to AD squared. AB is 6, so AB squared is 6 squared, that is 36. BD is 2, so BD squared is 2 squared, that is 4. Plus AD squared, AD is x, so AD squared is x squared. In conclusion, we found out that x squared equals to 36 plus 4. 36 plus 4 is 40. We took out of this equation and found out that x equals to the square root of 40. The square root of 40 is 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. I'll repeat again, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, thank you very much.